Good evening, students. Today we are going to learn very important property of the carbon compound called catenation. So what is this catenation? That we will learn. After understanding the catenation, we can draw the various possible carbon-carbon chains, and drawing the possible carbon chains give rise to another property called isomerism. So what is this catenation? The consequence of catenation is your isomers and isomerism. We had already learned the other important feature of this carbon as tetravalency. Means carbon can form 4 bonds. These 4 bonds can be with the other atoms, or 1 or 2 or 3 bonds can be with the carbon itself. Means one atom of carbon with the other atom of carbon. So that tetravalency we had learned. The other property like allotropism, we have already learned. So let us start with this catenation. A student, catenation simply means it is your self-linking property. So self-linking property is called catenation. Say I want to link with myself. Is it possible? Linking with my nature means if there is another Sujit, then if one Sujit is linked with other Sujit, then it is called as self-linking. Okay, so link or bond is always formed between 2 or more atoms. So here this link means bond, and self means same kind of atoms, because bond is always formed with at least 2 atoms. So one atom cannot form the bond with itself. But this self-linking indicates means the atom of same kind are linked together. Means bonding of same kind of atoms. Same kind of atoms. We had also learned different elements give rise to different type of atom. Means for one element all the atoms are identical, and they say example if we are considering say carbon, if we have large number of carbon atoms, then one carbon atom may link with the other carbon atom. So number of carbon atoms we are taking, surely it must be greater than 2. The carbon is denoted by C. If we are denoting the 2 carbon atom by C and C, so C, one of the carbon atom is able to form the bond with other carbon atom. But just forming one bond or linking with the other atom is not the catenation. Like hydrogen and hydrogen is also able to link with them. Then what makes difference with the catenation? Catenation simply means this linking is so that it is able to form a very long chain. Means the first carbon combined with the second carbon is able to combine with the third carbon or link with the third carbon is able to link with the fourth carbon, so on. Okay, but see, hydrogen can link with other hydrogen, but this hydrogen cannot further link with the next hydrogen because of their valency. Are we getting? So catenation simply means self-linking property which leads to formation of long chain of same kind of atom. So this leads to bonding same kind of atoms to form long chain. Okay, it is this one. So this way a long chain have to be formed. So let us define the catenation. What is this catenation? So definition many times asked. So definition is equally important. So write the phenomena of linking or bonding of atoms of same element to form a structure like long chain. So like maybe a long chain or ring or both chain and ring or both so this chain and ring that will form to give a larger or bigger molecule, bigger or larger molecule. A student, this property or this phenomena by which the same kind of atom means the atom of same element means atoms, it is not the atom only, it is atoms of same element is able to form either long chain or long ring, or one part have the chain, another part have the ring. These things are possible. As a result, a bigger molecule is formed. How is that? Even from the simpler to the bigger, one is able to form. So the chain formed, the chain formed students, here the chain formed may be your straight or branched. The chain formed may be straight or branched. How is this? This thing we will understand. Or having ring in one part. These things. And they may contain single bond, double bond, or triple bond. So the chain may contain single bond, means it is always covalent bond, student, or double bond or triple bond also. But note that 4 bonds between 2 atoms is not possible. Why? In more detail, you will learn in higher standard that this Covalent bond are of the two kind. One is called sigma bond, another is pi bond. Their orientation are perpendicular to each other, therefore their electron sharing is not possible, because electron try to repel each other, therefore the electron which are very far away, they cannot link. Okay, so up to 3 bonds they are able to form. So what these are? So these two are the important property. Now let us take example. It is the carbon which is able to form. So carbon bonds are formed, but not only the two carbon, means one carbon will attach with the other and the second with the third one, the third with the fourth one. This way a chain is formed, or a link or a straight chain is formed. It is also possible the two carbon, third carbon, fourth carbon, fifth carbon, sixth carbon, seventh carbon, eighth carbon, say ninth carbon. Is this two same or different, whether it is a straight chain or branched chain? A student, this is also straight. If you are thinking that there is just change in direction, then it is not this. A straight chain simply means it have only two terminals. That is the method to identify the chain in chemistry. Only two terminal means only two ends are there. If you start from the one end, you are able to reach to the other end only. You cannot have more than one path. That is only one path. Now whether this is drawn straight, so it may be drawn straight, or the curved one may be drawn straight or zigzag, but it should have only two terminals. So you are starting from the beginning. Let us consider you are starting from here. So first carbon, second carbon, third carbon, fourth carbon. Then obviously to reach to the other end, so this is the other end, you need to turn. So these turns are not considered as the branch. Fifth, sixth, seventh, eighth, and ninth. So right, that is turns. So this zigzag means turns are not branching. This is very important thing you need to understand. So here I am explaining carbon-carbon chain is formed. Then what could be the possible type of chain? I'm just considering the carbon. Other element could be the sulfur and phosphorus, but their chain are very limited. They can form the chain length up to 6 or 8 carbon 8 atoms only, means 6 sulfur or 8 sulfur or 4 phosphorus, 6 phosphorus, only this much are possible. But for carbon and carbon, it could be the carbon up to 100 also, even up to 1000 also. So how it? So student, whether this link or the chain are straight or branched, for that you have to start from the one terminal and you have to go to the other terminal. Then if there is only one possible path, means one path, whether it is zigzag or straight, then it is called as the straight chain. Whether you draw this second one like this one, or here the second one may also be drawn as the same. The second one may also be drawn as, see, total 9 carbon. You may draw this in the straight fashion: 2, 3, 4, 5, 6, 7, 8, 9. Both mean the same. Whether you are drawing in jig fashion or whether you are drawing in a straight, both are same. So both are same. This we have to keep in mind. Are we getting? Then
Sir,
what is this branching and zigzag? Yes, tell me.
sir, can you explain why turns are not branching?
Yeah, I'm going to explain that by taking other example. So student, just a straight chain means if you are starting from the one terminal and trying to reach to the other terminal, then you have only one path. That is the method to determine 4, 5, 6, 7, 8, 9. Both are same. Getting? But if anyone is taking like this, understand the next. By that you can understand it better. So third, if I am taking like this, say 1, 2, 3, 4, 5, then 6, 7, then I am going to add one more on the left hand side, say 8, then say 9, then say I'm writing here one more, say a student. Now again, here to know whether it is a straight chain or branched chain, just you have to mark the terminals. How many terminals are there? Just mark it. One terminal where the carbon is free means it is not connected with the other carbon, they are the terminal. The two terminal, the third terminal. So wherever more than two terminals, they are obviously branched one. Getting? Here we are getting only the two terminal. What are the terminal? These were the first terminal and it was the second terminal. Okay. So first terminal, second terminal. But in this case, how is this branching? If we start numbering or counting, then we can say like this. I'm going to start with 1 to 2, then to this one, then I have to take a turn, obviously. Now on reaching to this carbon, getting, which is marked in yellow, I have two possibilities. Either I can take a turn to left, or I have the other path to move right. So wherever branching, it simply means two possible path will be there. It's so simple, student. Just you have to keep in mind. Otherwise, you can never understand isomerism. So here branching occur. So branching at this carbon, right? For this, no branching. Are you getting? So branching doesn't mean, or branching do not mean the turn. It is just a turn. Just a turn. And these we have drawn on the paper, but practically these atoms are oriented slightly different. Okay. So a student, branching always means two possible path. So it gives different possible path. Possible path. Why not branching? It's a term as no new path. So if any new path is able to generate, means the two paths can be followed, or if there is two or more possible path at particular carbon, then that carbon is called the branching. Okay, or it is like the junction, means joining of different chain. Getting? So if I start the numbering, then how I can get the number 1, 2, 3, 4, then I may write 5, one may go on left, 6, then this is 7, or one is also free to take after this 5, one is also free to move this way. So one may take this path, means after 5, this as 6, this as 7, this as 8. One may take like this. Then how it should be numbered? Whether I shall take this as 6 or this carbon as 6, which one is correct? This is beyond to your scope. This you will learn in class 11. Okay? There is UPSC nomenclature, there you will learn more. I will give you certain hint while I will discuss this nomenclature. Just only one rule I will explain. Here, you have to look for the terminal. Here we are getting starting from 1 to 5, means started from terminal 1, reach to the carbon where there is branching. I have two possibilities. So moving on the one path, say on left, I can reach up to 7, but moving on the other path, I can reach up to 8. So those which is able to give the longer path is preferred one. Therefore, right hand path of numbering means 6, 7, 8. This is preferred, and this is not preferred. In nomenclature exclusively, this we will learn later. So if I want to number it, then I shall number something different. Okay, or I shall start again numbering 1 dash, 2 dash, like that. Okay, or in nomenclature we will learn this itself is now taken as another small carbon chain which is attached with this bigger chain. Okay, so this is the other small chain or a straight chain which is attached. So what we are getting in branching, I can have more than one chain. Okay, so just writing as a term is not a branching. So branching always means it must have more than two terminal. Yes, Neeraj, now you ask if you have any doubt, or is it okay now?
Yes, sir. No problem.
Getting? So student, the important or key thing is understand the turn and branching. Turns are not the branch. Branch always mean you have more than one possibility or more than one path on which you can number or you can move. So simple method of observing, just count the end carbon or the terminal of carbon, that will give us the branch. If it is 2, it cannot be the branched one, irrespective of how many turn it is taking. But even if you are writing this a smaller one, say the third one I am writing, say if I am writing like this, C, 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 and other C itself here, whether it is a branching or not. A student, interesting thing is, in this 4 carbon itself there is branching. So this is also the branching. Branching. Why? 1, 2, 3 terminals. How to number? Those things we will learn in our topic nomenclature of carbon. So student, branching simple means you have to start with 1, and on any of the carbon, if you are getting more than 2 carbon, say you have started from here, you have reached to this carbon, and at this point you are getting one was already this first carbon, the other carbon It could be this one or this one. Get it? So if more than 2 carbon is there, then only branching can be understood. See how is this 2 number? See, coming to the second one, here we are observing that, say the term number 4. How many carbon are associated with this carbon? One is the carbon number 3, another is the carbon number 6. Sorry, 5. So only 2 carbon is associated with that carbon. It cannot be branched, irrespective of their orientation or their turn or zigzag or way of drawing. Is it okay, student? So I'm going to write everything. So branching simply means you have to observe carefully that one carbon is attached with more than 2 carbon, then only branching will be there. Okay, so right, the branching यस हाँ हाइड्रोजन से वैलेंसी फिल करना अभी हम करेंगे इसके अलावा कोई डाउट पूछ रहे हैं तो बोलिए अदरवाइज हाउ टू राइट द कंप्लीट मॉलिक्यूल दैट आई विल एक्सप्लेन ओके हाँ बोलिए
सर
हाँ
डबल बॉन्ड ट्रिपल बॉन्ड नॉट फॉर्म्ड इन ब्रांचिंग
मे फॉर्म नो अभी हम दिखाएंगे ना आपको अभी हम पूरा कंप्लीट स्ट्रक्चर जब वैलेंसी फिल करेंगे तब आपको दिखाएंगे मैं तो अभी जस्ट ये बतला रहा हूं आपको कि चेन कैसे कैसे बन सकते हैं देखिए आई एम एक्सप्लेनिंग राइट नाउ दिस पॉइंट ओके तब देखेंगे कि चेन के अंदर कैसे कैसे बॉन्ड बनेंगे कैसे रिंग बनेंगे एवरीथिंग वी विल सी कैसे अभी हम वैलेंसी फिल करेंगे अभी तो जस्ट हम आपको बता रहे हैं कि हमारा चेन का मीनिंग क्या होता है ब्रांचिंग क्या होता है अभी तो हम यही 2 टर्म बता रहे हैं ओके सो लेट अस राइट फ्यू थिंग अबाउट द ब्रांचिंग हाउ टू आइडेंटिफाई स्टूडेंट ब्रांचिंग और ब्रांच्ड chain it simply means the molecule have more than 2 terminal of carbon so the molecule must have more than 2 end carbon terminal it simply means if it is chain I am talking for the chain means open ring means open one I am considering if I will consider the ring then it gets slightly different if I am talking in the term of terminal so to accommodate that if it is the ring then one carbon must have to attach with more than 2 carbon one carbon atom must attached with not 2 but more than 2 to carbon to other carbon atom better to write like this to other carbon atom other in place of carbon it may be nitrogen or phosphorus also okay that way branching is also possible but these things are beyond to your scope you will learn this thing in your class 10th 12th or even in graduation and higher standard you will learn okay so do not get confused with the other atom I'm always stuck with the carbon more than 2 other carbon atoms okay student it's simply meant it means in other term what we can write at a point I have 2 different paths see for moving on the carbon say in the second one even we were taking the turn at carbon 4 then again the turn at carbon 6 but it was not giving the branching because only one path means moving ahead only the same path we need to follow but while considering the branching in case of branching we had observed that at this carbon 5 I had 2 possibilities okay so coming here either this way or this way These were the two possibilities. So all these things we have to take care. Even no need to think from starting with this terminal, say the terminal C1. You can take any other terminal, then still you will get the same. This way, or if one is interested, one may think, no, he is going to start with the terminal 3. Then at the terminal 3, he will come like this, see. Now coming to this, again there are two possibilities, either going straight or going this way. These are the other possibilities. So get it? So branching always means more than one possible path. Here we are getting in a straight chain, there was only one path. So here we shall use that term also to understand in case of a ring. So write more than one path. More than one path at least on one of the carbon. At least on one of the carbon. It is called as the branching. Student, now a straight chain, branch chain we have understand. Now coming to the ring. What do we mean by ring? If we are considering the ring, a student, 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon, 6 carbon, coming back like this. Okay, it may be possible 1 carbon, 2 carbon, 3 carbon, 4 carbon, ring closed. Okay, it is possible to form like this. A student, why 4? Why cannot we take like this? 1 carbon, then 2 carbon, then 3 carbon, ring closed. Yes, it is able to form, it is able to form, this is also able to form, but the formation is very rare. Why very rare? That you will learn in higher standard. While this bond and this bond, these two bonds are formed here on the one of the carbon in ring of 3 carbon, then the repulsion between these two bonds is very high, because this angle is very small. What will be this angle? This angle is 60 degree. So while the two things means the two quantities or same bond or same kind of electron are placed very closer to each other, there will always be repulsion and it will try to move away. Therefore, this compound means theoretically this is formed, but practically it is found very rarely. So it is also possible, but very rare. Getting how it? Even you will learn all these things in higher standard. With this carbon, if you want to form a double bond, yes, you can form. Why not? We can form. We can form like this. Anywhere we can also form a double bond. So those double bonds I will also explain. So ring simply means the closed path. So write ring. So at least one closed path, that is called as ring. Now combination. So it is possible that one carbon attached with the other, with the other, with the other, see, and this with the other. See, one of this is our ring and this is our another chain. So in this case, there is branching at this carbon, student. Here branching occur. Whether there is a branch in this, any ring, no branching. Getting no? So here no branching, though it is closed, but here it is the ring and this is the straight. These two are connected by this branching. Here is the branching. Are we getting this much? So these things are very important. Just you need to understand. Okay, student? So it is like this one. Now, this way we have observed different kind of a structure are possible by combining the carbon. But how the carbon combines? How many bond it can form? So to satisfy that, the concept of tetravalency or the property of tetravalency have to be kept in mind. So right, the student, I had explained, keep in mind, I had explained this point. Carbon chain may be a straight, branch, ring. They may contain single, double, triple. I will explain now. So with reference to this, I am taking the next. So the tetravalency of carbon is satisfied in forming any compound or any chain or ring. Okay, for this it may be possible that two carbon atom may form double or triple bond depending on the presence of other atom like hydrogen. Okay, so tetravalency of carbon is satisfied in forming any compound or ring or chain considering the number of hydrogen atom in place of hydrogen atom it may be some other atoms also. They are called as heteroatom or other atom which is given. So considering the number of hydrogen atom, it may form double or triple bond between two carbon atoms. So a student, it is very important thing. Please understand this. By this, you are able to draw any structure. You are able to draw any isomer. So a student, here I have written or I have loaded all the terms very heavily. First means 2 or 3 rule I have clubbed together here. See how the bonding. So for following the bonding, the tetravalency means if you are considering any carbon atom, it must be able to form 4 bond, not less, means neither less nor greater. Means let me take one. So if I am given with carbon, then this carbon means each of the carbon have to form 4 bond. If there is sufficient number of hydrogen, then it is able to attach with hydrogen. So the molecule form here is carbon is 2 in number, C2, but counting the hydrogen, 3 on one carbon and 3 on other carbon, H6. So this was the structure. By the way, if you are given with C2 and H4, then what you will do? A student, first you will link the 2 carbon, later on you will attach the hydrogen or distribute the hydrogen considering the tetravalency. A student, if you have, or if you are going to distribute the hydrogen, then first you draw the 4 bond for each carbon. That is the first thing. Later on you will start distributing. Here we have only 4 carbon, sorry, 4 hydrogen. If I am giving these 3 hydrogen at this place, what about the other? Say one more is left, 1 hydrogen, then these 2 bond cannot join with each other. Okay, so these 2 are left free. Means for this carbon the tetravalency is not satisfied. Means the 2 electrons are free for this carbon. Getting? Because the bond is not formed with the other atom, or the electron is not shared. It simply means that. It simply means it is like this only. So 2 electrons are there. Or, so what could be the other possibility? So the better way, 1, 2 means the 2 electrons. Each carbon have the 4 electrons. So draw the 4 electrons. Now for linking these 2 carbons, surely I have to draw at least or make 1 bond. Now 4 hydrogen have to be distributed. For that, if I am going to give 1 hydrogen here to form 1 bond, other hydrogen here to form other bond. Similarly, the other hydrogen, the third hydrogen for the first carbon, and fourth hydrogen also for the first carbon. These 2 electrons which are belonging to different carbon, they can also join, okay, to form what? Called as double bond. So therefore this electron or 1 more electron pair is being shared, and this way a double bond is formed. So this is the correct structure. Get it? So this is how we have to draw. The same thing I had also explained in tetravalency. So student, all these things are written here. First we need to satisfy their tetravalency for all the carbon. So the tetravalency of carbon is satisfied. This is the prime requirement. Otherwise, it cannot be a stable molecule, or that molecule or that compound cannot be formed. A student, by the way, if any student is thinking like this, so let me consider this as 1, this as 2. The third structure, if any student is thinking like this, say C3H8. Okay, my purpose is to show you, say this. So can I make like this double bond, hydrogen, 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 hydrogen. H is our 8, 3, 2 the 6. Can I make like this? A student, can I make this structure like this? What is the problem with this structure that I have drawn? Yes, tell me quickly.
Sir, middle carbon has 5 bonds.
Very good. That is one thing. Here we are observing whether tetravalence is satisfied. Rather than satisfying, it becomes excess, which is not possible at all. It is not only the middle carbon, but even if we are counting the end carbon, observe this end carbon. How many bonds are there? Means how many electrons sharing? 1, 2, 3, 4, 5. For middle carbon again, 1, 2, 3, 4, 5. Though for the left carbon it was 4 only. So right, this is not possible. So this is not possible. As why not possible, students? Very simple. What has happened here? The carbon have valency more than 4, which is not possible. carbon have valency less than 4? Not possible. So always tetravalency have to be satisfied. As carbon with more than 4 valency. 4 valency means 4 bond. A student, how much valency? Say that much bond. Not possible. Okay, student? So never make such a mistake. It is the learning. Now, so what is the correct structure for this? Any of you may draw, or all of you have to draw. A student, just if we remove this double bond, so it is wrong one. 3. So after drawing, you have to satisfy the remaining one. How to satisfy? So hydrogen, if the number of open bonds means bond at these carbons which are not between the carbon and carbon are able to satisfy with the hydrogen, means the same number of hydrogen is available, it will get satisfied. If the same number of hydrogen will not available, then these two bond will link. Okay, here we are getting that the hydrogen is 18 number. Put it 1, 2, 3, 4, 5, 6, 7, 8. It's okay. So this is the correct structure. A student, draw one more structure. Or let me take one more structure. The fourth one. Why so? So let me take the fourth one. Yeah, let me take the fourth one. Say you have to draw the structure of C3H6. What you will do? Yeah, draw quickly. So this catenation and isomerism and bonding, all these things are integrated. So we have to learn all these three things together rather than just learning the definition or just remembering the definition. Concept have to be developed. So yes, student, first you draw the 3 carbon. Draw it quickly. So draw the 3 carbon. First you link these 3 carbon with the single bond. If you have any doubt, you may draw the other bond or the other electrons which will be shared by this. So let me draw like this. Now you have to give the 6 hydrogen. So for the 6 hydrogen, one may think, okay, just can I give the 3 hydrogen here, 3 hydrogen here? Is it okay? A student, then what about these 2 bonds? It is not possible to leave any of the bond open. Getting? Therefore, you have to distribute this hydrogen carefully. What I shall do? Yes, student, if I start thinking like this, say rather than giving this hydrogen to this one, if I leave this hydrogen as it is, then I am able to form or connect these 2 bonds together, and the only one hydrogen that we had removed from here, if this is given here and these bonds are, means these electron are shared with the carbon itself, then this can give the correct structure. So remove this hydrogen from here, this bond from here, and club this with the double bond. Are we getting like? So this way we have reached to the correct structure. So these things you have to do practice. By practice you can get these things very easily. So it is very easy. One of you may think, sir, why you have removed this hydrogen? or why you have just formed the double bond at these two? Can I form here? Surely you can do, a student. It is up to you. So irrespective of whether double bond is done between the first two carbon or the last two carbon, that doesn't matter. So let us draw the other structure. Or, so let me draw it here. The three carbon that I am connecting. Now at these three carbon we have to fill the bonds, means tetravalency for each carbon. Let us give the hydrogen, 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 means three hydrogen here. Then give one hydrogen in the middle one and two hydrogen at the last one, and these two bonds have to be joined together because it is nothing but it is representing one electron. So just I will draw it as one of the bond. So this way the double bond is formed. So it is our double bond. So whether you draw this structure, means double bond between the last two carbon or first two carbon, mean the same thing. A student, even many a time our student or some of you may think, can I draw like this? You are free to draw any kind of a structure, whether it will be the chain or branched. No, changing the orientation doesn't mean it is the branching. Are we getting? Because only two terminals are there. So still you can put the three hydrogen at one of them, one hydrogen here, and say double bond here. So while drawing this double bond, I will be left with only two hydrogen or two more bond for this last carbon. So I have to fill only two hydrogen. Okay. So whether you draw like this, all mean the same. Are you getting? So these are the important things that you have to keep in mind. Whether you draw the straight in the that straight, double bond at any position, whether you draw the say in turn or zigzag, again double bond can be between these two carbon, it can be here also. Let me draw that structure also. So student, these four structure are not different. That is the point that we have to keep in mind. So, or even one is thinking like that, say the carbon is drawn here and double bond is drawn here. Then in this case, the first carbon, two bond is already drawn. So only two hydrogen can be fixed here to maintain the tetravalency of this carbon. Okay. Now for this middle carbon, already three bonds are drawn. So only one hydrogen can be fixed here. But this last carbon, only one bond is there. It means three other bonds are there, or three other bonds can be formed. So form the three other bonds at this carbon. So hydrogen, hydrogen, hydrogen. Again, whether drawing at perpendicular or at certain angle, that doesn't matter. Okay, student? So it is this one. So this way I had explained all the possibilities, the way of drawing. Getting? So a student, all these four are same. That is, we have to learn or we have to understand, because while drawing the isomers, a student are getting confused. So one is drawn in turn, bond is here to here. So unless or until there is change, it will not be the new one. So it was this one. So this way we have observed the very first thing that we need to keep in mind is the tetravalency have to be satisfied for each carbon atom. Getting? By this, or for satisfying this tetravalency, the chain drawn may be your ring one or a straight one, and for completing the structural formula of given compound, you have to take care of the hydrogen. So depending on considering the number of hydrogen atoms, this double bond, triple bond, have to be drawn. So that I was explaining. Is it okay, or a student still have any doubt? Then please ask to me. Now, a student, another interesting thing. Come to this fourth one. They also C3H6 I had taken. Okay, student. A student, one of you may think one carbon, other carbon, the third carbon. Okay. One may think, why not this carbon can share with this one rather than double bond? Is it possible? Try to satisfy the tetravalence. If it is satisfied by considering the 6 hydrogen, then this structure is also possible. Now observe for the very first this carbon. For this carbon, 2 bonds, one here and other are with this carbon is already formed. So what is left is the two other bond. For this second carbon, again the 2 bond, one this and another one is this is already formed, but still we can put 2 more bonds. Same is also true for the third carbon. So draw that for this carbon, already the 2 bond, one is this, another this is there. So 2 more hydrogen can be kept here. Means 2 more bond can be kept here. So try to draw this. Means, so for the remaining part, you just give the hydrogen, 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 hydrogen. Yes, 6 was there and all the 6 get consumed. So it is also possible, student. Are you getting? It is that much interesting. So here we are getting this one, or whatever the earlier structure that we have drawn. So it is the our ring one. But in this ring, without double bond. This we have to keep in mind. Because if you are drawing the double bond at any of the position, then the number of hydrogen given 6 will not be accommodated. Or see like this, the carbon, carbon, carbon. One of you have drawn the double bond here. Then if you are trying to put the 6 carbon just by giving the 2 carbon to each, 2 hydrogen to each carbon. See here, for this, we are observing that this carbon and these 2 carbon have more than 4 valency. 1, 2, 3, 4, 5. It is not possible. Okay, student. So this way you have to think, you have to draw. This chapter is totally mathematical or analytical one. So you have to just understand the basic principle. You have to draw, you will get the result. So it is not possible. So that's why without double bond. Yeah, tell me.
Sir, if all have double bond, then no hydrogen will be needed. Is
That
it
I have
possible?
explained earlier also, but the same thing you are asking, then I will explain that one once again. So student, here just observe this cyclic or ring is also called as cyclic. Okay, student. Or the other that we had formed here was only this one. So these are the 2 structure for the same molecular formula. One we have got this ring, another this one is our straight chain with double bond. Means one double bond is equivalent to just forming one ring. So these 2 are the different structure. Student, now this is cyclic, this is linear or straight. It have entirely different structure or different behavior, because the second straight chain have double bond, but the cyclic do not have double bond. So wherever double bond, that group is called your alkene. This we will learn in more detail. But this is, though it is cyclic, but it is your cyclic alkane, ALKAN. Therefore, these two are entirely different. So these two different structures are called as your isomers. Isomers of each other means for the same molecular formula, different structural formula, then they are called as isomers. Okay, student, and this phenomena is called as isomerism. Okay, like allotropes and allotropism. Okay, so the phenomena of existence of more than one structural formula for the same molecular formula is called isomerism. The different structure that we have drawn for the same molecular formula, they are called as the isomers. These two isomers have different properties. Okay, like here we have seen one have double bond, another one is the cyclic. One is alkene group, other is alkane group. It is also possible that in the same alkane there may be one is linear, another one is the branched one. So those things we have to see in more detail. Now Vivek is asking one thing: why cannot be formed just C2? Can be formed like this? Say. So if we are considering one carbon, another carbon, he is saying that there are 4 electrons.
Sir, C3.
C3. Only C3. Okay. Okay, let me see. So if I am taking like this, then yes, you can share one electron with one. Okay. The second electron with second, the third electron with the third. Up to this much you are able to form. But the fourth electron, you cannot join this. Okay. Why? Technically or more detail you will learn in higher standard, because this one bond is the straight bond or called sigma bond, and these two are the pi bond. So these have lateral overlapping. But this third electron, which is lying on the other say z axis, they cannot overlap with each other. Therefore, it is not formed. But that technicality or those things are not required here. But another simple thing that I want to tell you, by which you can keep in your mind, and that may also present in your book, is that if you are forming this C2, say if you are forming like this, the 4 bond, getting, then between these bonds means all the electrons have come closer to each other. Now we are knowing that in this carbon, electrons are trying to lie as much apart as they can, means because of their electronic repulsion. But forming such 4 bond together, all have to align together. They have to come in one line. And for the other carbon, they also have to come in one line. Are we getting? Means if the orbit is circular, then while they are coming at one line, this repulsion increases so much that it cannot form a stable bond. They will just get repelled or they will just disintegrate. So up to carbon 3 bonds are possible, but the fourth one will always be the open one for the other carbon or any other atom. So write only this one or complete this one. So C2 is not possible. Why? So write in your language only. Because of larger repulsion between the bonds if formed. Though it is not formed, but if it is formed, the repulsion is so dominant that the atom become unstable and it gets disintegrate or destroyed. Okay student, so this much is enough for you. आपको सिग्मा पाई ये वो सब नहीं पढ़ाएंगे, वो सब आपको नहीं चाहिए. ओके स्टूडेंट, नाउ कमिंग टू दी C3. अभी क्या मैं जस्ट C3 बना सकता हूं क्या? आप सोच लीजिए यहीं से. ड्रॉ योर स्ट्रक्चर. By drawing the structure you can understand whether that is possible or not. So right, this is true, this is possible, but this is not possible, or rather like it's not possible. Means 4 bond between the same. So not only the carbon, even with the any other atom, the 4 bond with the same kind of atom is not possible at all, excluding coordination compound. You will learn in higher standard. Okay, chemistry is not the end up to your standard, or not only this much, many more things are to learn. You will learn in higher standard. Now one of you are asking for, say, yes Vivek, tell me your molecular formula. C3.
Sir, cyclic. Yes, sir.
Okay, draw. Try to satisfy the valency. Draw it. Have you drawn, or shall I draw? Yes student, I hope so. You people might have drawn. नहीं है तो मैं अभी आपको बना के दिखाऊंगा. Hey student, draw these 3 carbon like this. Say C, C, C. Now for satisfying, you may think, okay, for the second carbon, say for this, or understand like this, a bit like this, better to understand like this. 1, 2, 3, but the second carbon or middle carbon, only 2 bonds are already formed, 4 at the end. Now one may think, okay, 1 electron is this, commit here, commit here. Okay, another may think, okay, for this, one may think, collect it here, connect it here. So what is the structure that you are getting? C double bond C double bond C, but still the 2 electron at the end of, or the terminal carbons are not shared. So tetravalency is not satisfied here. Getting? Vivek, कभी आपको आंसर मिला? So no tetravalency. हाँ बोलिए. साइक्लिक बनाएंगे? बनाता हूं, अभी बनाता हूं. Not possible. So no tetravalency here. देखिए उस केस में मैं आपको बतलाता हूं क्या होता है, फिर अभी आपको 11-12 का कॉन्सेप्ट बताना पड़ेगा. So no tetravalency. One may say like this. Some of you may also think like, okay, rather than this, we may join this bond itself. By the way, if anyone is thinking, then let me draw that also. Triple bond C. Okay, but still here 1 bond left, means 1 electron left as it is, but with the second, all the 3 electrons remain as it is. Okay, so for this to not satisfy, it is one thing. Now coming to the cyclic one, it's good thinking, but practically this is not feasible. So the 2, so rather than drawing in a straight, I have just tilted the 2 carbon like this, and I have just drawn it. Okay student, the 2 electrons are here, 2 electrons are here, surely they can bond it. Okay, it means it appears that C3 can be formed. It appears the valency are satisfied. So valency satisfied. But what is the problem? The problem is that these 2, what was the problem with these 4 carbon, student, what was the problem with these 4 bond between the 2 carbon? These bonds are quite closer, so they repel each other. See, in the similar fashion, if you are considering any one of the carbon, then you can see that this carbon with these 4 electrons will try to come closer to each other because this is forming a triangle. So this angle can be maximum 60 degree. So because of this larger repulsion between these bonds, this also not possible, or practically it is not found. Okay, but during the reaction or during the research, it is found that during transient moment, this C2 with this structure is formed. Okay, but it is not existing in free state. We are not getting the compound like C3. Okay, but theoretically it is possible, but not existing. Why? Due to larger repulsion. So because of the larger repulsion, it becomes unstable. So if anything is unstable, it cannot survive. Get it? So a stable situation is always required. But see, a student, if you are taking like this, if you are drawing the bond like this, say C with this carbon, with this carbon, with this carbon, this carbon. Yeah, this is possible, student. This is possible. So it exists. But here do not think all are these C, or even increasing this, all like this. Okay, this is rarely possible. I mean, theoretically it is possible, but practically it is not existing because of the same reason. Overlapping is not possible. Larger, I mean, the bonds that you will learn, sigma bond, they are spherical. This is the pi bond, they are dumbbelled shape. It is like this one. So this is the sharing, this is the sharing here, this is the sharing. So if we are taking this 4th one, then that sharing with this is again not possible. So this one, this one, this one, and this one, again this one to this one, this sigma and pi structure, this. But the 4th, if you are drawing now like this, then that creates problem in overlapping. Yeah, practically it is not existing. But these things are beyond to your scope. So leave this. It simply means if the 2 bond in cyclic compound closer to each other, just 1 or 2 are there, that is existing. But for a cyclic compound with all the double bonds are not existing. This is the thing that you have to keep in mind. Okay, so but it exists because only 2 bond, larger chain means the repulsion is being reduced. So it is one thing. So this way we have drawn. A student, one may draw like this, the structure like this, say carbon, another carbon, 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 with this carbon and this carbon. Yes, surely it is possible. A student, you can put the double bond or even rather triple bond also at any of the places. So considering these 2, I can place the triple bond here. The other one, say carbon, 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 other carbon, this carbon, carbon, triple bond here. Can I form this, student? This structure is feasible. It is also okay or not?
No, sir.
Why? Very good.
So
Other
5
students
bonds.
are sleeping. Observe this carbon, 3 bond and 2 bond, total 5 bond. So because of this structure is not possible. So these are the key things that we have to keep in mind. So it is not possible. It is possible. So this tetravalency is very important. A student, you may draw like this one also, carbon, 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 this, double bond in between one of them, it is existing. Okay. What about the other? Other are satisfied by hydrogen. So 1, 2, 3, 4. So only one hydrogen will be at this carbon. So I had kept only one hydrogen. But for the other carbon, two hydrogen can be kept. For this carbon, one hydrogen can be kept, correct? For this two hydrogen, for this three hydrogen can be kept.
No,
Is it
sir.
okay, student? Or any doubt? A student, again, you
No,
people
sir.
are sleeping. This carbon, otherwise this have the 5 valency. So this structure, it is like this one. Are you getting? So these are the possible. So what is the formula for this? Is our 1, 2, 3, 4, 5, 6, C5. How much H is there? 2 to the 4, 1, 5, 2, 7, 3, 10. It is this C5H10. What could be the other structure of C5H10? A student, other structure called structural isomers, those things we will learn later. But one may draw like this 3, 4, and 5. Then only 10 hydrogen. So one may draw like this. So draw the two bond here, then give it. You can get. So for this, three bonds. Any problem with this structure, or is it okay? Again, we have done one thing wrong. This hydrogen have to be removed. So therefore, remove this. It is possible. Observe 3 to the 6 to 8. Other structure also possible. Why this much? Yes, triple bond is also possible. So all these structure we will learn tomorrow. Okay, student? We shall stop the class here. So I may take the triple bond at one of the end or any of this, giving one hydrogen. This have the two hydrogen. Considering this triple bond and this, no hydrogen is possible here. Otherwise, it becomes pentavalent. This have the two hydrogen, three hydrogens. So please do the practice of drawing the structural formula. So for this, the cyclic is possible. This triple bond is called alkyne because it is the triple bond. This is the double bond. It is our alkene. Spelling difference is there. This is also alkene, but it is the cyclic. So to make differentiate, it is like alkane structure is not possible for this. If all are the single bond, then this structure cannot be drawn. Okay. So alkene with two double bond or one cyclic and one double bond. So these are the possible. Similarly, you can draw many more structure. Those things we will learn tomorrow. Okay. This bond may be here or maybe here. It may be shifted. Accordingly, the hydrogen have to be shifted to the other one. So this way, all the possible structure you need to draw and you have to think for that. Okay, student. So here, regarding catenation, we have learned everything and we have written everything. Let me just explain once more. So student, catenation simply means, for remembering this, you have to keep in mind it is a self-linking property. Self-linking doesn't mean one atom with the other, because linking means always forming the bond. Bond formation possible with more than one atom. Okay, so this self indicate means same kind of atoms. Yeah, this self have that meaning. So this linking doesn't mean just forming the bond between two atoms of same kind. It is okay. Even oxygen, no, it is not the self-linking. By this way, they have to form a longer chain. If it is able to form such a longer chain, then we can say it have the catenation. Otherwise, we cannot say these elements have the catenation. Therefore, oxygen, hydrogen, they are forming H2O2, N2, but they are not showing the catenation. Catenation means forming the long chain or a ring of the same kind of atom. Okay, for that I have taken the carbon. So for linking the carbon, at least one of the bond have to be formed. So this only one bond means it is called as your single bond. But depending on the hydrogen, more electron may be shared between the two carbon, that leads to double bond or triple bond or even the cyclic also. So the chain formation may be the straight or having ring in one part, or maybe the ring itself. So ring is also called as the cyclic. So maybe cyclic or a straight one. Now this straight or the open one, maybe or the be branched or unbranched. So very first is this is the straight or called as unbranched also. But in unbranched there is only two terminal. If we are moving from one terminal, we are able to reach to other terminal. So just drawing in different orientation or zigzag is not a branching, but branching means at any carbon we have at least two possible paths to move along the carbon chain. Okay, so that means one of the carbon have to attach with more than two carbon, then only branching is possible. Okay student, it is this concept that I has explained. So branching, everything I had explained. With the branching, the cycling is also possible. So cyclic means connecting the end, forming a ring, that is called as the cyclic. So the key tool in forming this structure is their tetravalency and the number of hydrogen atom available. So considering this, different structure are possible for the same molecular formula. So for same molecular formula, if more than one structural formula is possible, such structural formula are called as isomers of each other, and this phenomena is called isomerism. Student, also we have learned C2 is not possible at all, or C3 or ring with only double bond or triple bond is not possible at all because of instability. This thing we have learned, that I had explained everything. A student, so first here I had talked for the carbon, but there are few other elements. So right, note other element like sulfur, phosphorus, sulfur and phosphorus, only these two or few more are there, are able to show catenation to a very little extent, to a, why this little extent? This little extent means only few or a smaller chain. So chain length up to, means for this first sulfur and phosphorus I am writing up to 6 or 8 is observed, but bigger than this are unstable and they are not able to form. One more is there, silicate, but those things are not in your scope. So if we are taking this sulfur, so sulfur, the 6 sulfur atoms are able to attach, even 8 sulfur atoms are also able to attach with the or among themselves to form a ring like structure. One more is there, write this silicon one, sulfur, and write this name silicon also, silicon because of this silicon. Even silicon is showing more catenation than the sulfur and phosphorus. A student, if you are considering the sulfur, then you can find that this sulfur atom is able to form the ring like this. Are you getting? It is the structure of. So here sulfur are attached. How many sulfur are there? 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Yes, 8 I have to. Getting? Like our S8. Getting? For satisfying, it can also attach with the hydrogen and other element. Similarly, phosphorus P6 is possible. Even P4 is also possible. Means 4 phosphorus or 6 phosphorus just combined with each other. Bigger than this is not possible. But for carbon, the chain or ring may contain even up to thousands of carbon atoms. Getting? So because of this characteristic, carbon means carbon can combine with the carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon, 6 carbon, 10 carbon. But 6 and 10 carbon are able to arrange among themselves, able to form the rings. So therefore, large number of compounds are formed. So write this because of, this is very important note, student, you have to keep in mind, tetravalency, which leads to the catenation also. Catenation, along with the tetravalency, the smaller size of carbon help in giving the catenation, because tetravalency is also for the silicon. Okay, silicon, germanium, they are also tetravalent, but they are not able to form big chain because their atoms are bigger. So student, write this because of tetravalency with catenation, this catenation means catenation to maximum extent and of catenation because of a smaller size of the carbon. So because of tetravalency with catenation, and in many a time this feature is not written, but this is also important, and in NTSE it is asked. So tetravalency, catenation, and a smaller size of carbon atom. Okay, this catenation itself is because of the smaller size of carbon, or maximum catenation is because of that. So because of tetravalency with catenation, the carbon alone able to form millions, even not millions, even it can go into the billions of carbon compound, which is even greater than all the compound formed by all the remaining element, which is even greater than all the possible compounds by all the remaining or other element or other remaining, though it get repeated. या तो अदर यूज करिए या रिमेनिंग यूज करिए. हाँ, इंग्लिश के लैंग्वेज में गलत हो जाता है अदर रिमेनिंग. सो बाय द अदर elements means if you are taking this carbon, total how many elements? Around 120 elements. So if you are taking the carbon on one side and other 119 elements on other side, then whatever the compound, n number of compounds, so compounds, their number is even much greater than whatever the compounds all of this can form. Okay, so this, therefore this carbon alone is able to form a separate branch of chemistry called organic chemistry. And the property of this carbon compound, this compound, their property is different from the compound formed by all the other remaining elements. So these compounds differ from other. So they are different from other. What these are? These others are. These other means it is like our this one. A student, as a result, this is studied as a separate branch of chemistry called organic chemistry. And all these compounds of the other element are called as inorganic chemistry. But this inorganic chemistry also includes the carbon dioxide, carbonates, bicarbonates, etc. of carbon. Why that? That we will learn later. Because here ionic bond is formed, but in compound or organic compound, ionic bonds are not there. Okay, this organic compound was first discovered by Hall. Okay, in the chemical, earlier it was considered that no organic compound cannot be synthesized in laboratory. So those things we will learn tomorrow. What is this organic compound? How the Hall prepared it from the ammonium cyanide? Those things we will learn tomorrow. So because of this characteristic, this carbon is called as versatile element, and it is studied under a separate branch of chemistry called organic chemistry. Okay, student. So the two important properties which leads to formation of large number of carbon compound is our tetravalency and another one is catenation. So never forget, though other properties are also assisting or helping it, but these two are the very important property. Okay, student, any doubt then please ask, otherwise I had explained everything. A student, for this sulfur and silicon, if you are considering the silicon, okay, so SO2 means basically this silicate it is forming, so it is also able to show the catenation. These are, this silicon is also tetravalent, tetravalent. valent, but not showing the catenation to that extent what the carbon is able to show, because silicon is bigger inside, so the chain form is not that much stronger, it gets splitted. But they are forming a special kind of compound called silicate, where silicon bonds are there. This you will learn in higher standard. So keep in mind, if you have to write the other element which are able to show the catenation, you must write the silicon, phosphorus and sulfur. If you are asked for only one, then prefer the silicon, after that prefer the sulfur and phosphorus at the end, because sulfur up to 14 it is possible. Silicon, so silicon chain up to 20 means 15 to 20, basically up to 14 are stable. If 15 is formed, it become unstable. 15 to 20 are found, but bigger than this, the chain for silicon is not found. Therefore, this silicon, phosphorus, sulfur, they are showing this catenation to very little extent. That's why carbon is very versatile. Yes, student, any doubt, then please ask. Otherwise, our student must.
Sir,
Yes.
sir, it is SiO2.
Yes, it is SiO2. ये हमारा SO2 नहीं है, SiO2. ये सिलिकेट एक अलग स्ट्रक्चर है, ये आप पढ़ेंगे, जिसमें कि सिलिकन का ऐसा एक बॉन्ड होता चला जाता है, ये फर्दर दूसरे सिलिकन से कनेक्ट होता है, ये तीसरे ये ऐसे ऐसे कनेक्ट होकर के साथ में इधर ऑक्सीजन कनेक्ट होता है. So those things you will learn in higher standard. SiO2 means silicon dioxide. This SiO2 is the constituent of silicate, which is not the single molecule, but this SiO2 get connected with each other to form a bigger chain structure. So SiO2 is the unit of silicate. I have written this. Okay. SiO2. Yes, sulfur से sulfur dioxide बनता है. So if you are just forming SO2, ये कोई कैटिनेशन नहीं है, ये तो बस सल्फर दो ऑक्सीजन के साथ ऐसे कनेक्टेड है. ओके, ये ऐसा है. Yes, student, any doubt then please ask, otherwise we shall stop the class here. No doubt? So write down your homework. You please do up to how much we can do. Student, you please try to draw these structures in your home. This functional group and other thing I will do later, but please draw the structure. Try to read up to this much. You first draw the possible structures. Already we have done this. So for possible structure, though this thing we will discuss later. Okay, nomenclature I have not taught. So right now, just giving the name, it become difficult. So yes, you please practice for draw a structure for C5H10, all possible structure. Okay, now means all possible structure. C4H8, C4H6, C5H8, इसके तो बहुत सारे बनेंगे. Okay, you have to try this. These four structure you please practice. Okay, student. Other thing for your mathematics, you please continue with that. Other your NTSE, those things please. So please focus toward your study. Yes, student, any doubt to any student, then they may ask. Yes, student, any doubt?
No, sir.
Okay, so can we stop our class here?
Okay, sir.
Yes, student, any student have any doubt, then they may ask.
No, sir, no doubt.
Other student only